The next series of lessons covers a number of important building blocks that we need to understand in order to properly use a select statement. Yes, I know you're really eager to get on with the business of selecting data from a table in a database, but rushing straight into things without first acquiring a good understanding of the rules involved can often lead to trouble. So I'd like to spend some time helping you avoid problems further down the road. To this end, we're going to explore some really basic things, but with a fair amount of detail and precision so that we don't have to wrestle with explanations of them while we're trying to perform more complex tasks later on. But while the concepts we're going to explore in these lessons are basic, they're not necessarily elementary. These are things I have seen students stumble over in many of the classes I've given over the years, and I have found that students tend to avoid a lot of future errors if they are given this information early in the learning cycle. So hang in there and be patient, and you'll see what I'm getting at as these lessons unfold. In this lesson, we're going to explore the use of the basic clause of the select statement to perform some simple calculations. In fact, that is exactly what the select statement does. It issues a request to the server for some information, much of which may need to be calculated, and the server sends back a set of results which the client program then formats and displays for us. It is true that, in the general use of a database, the information that we want to retrieve from the server can be found in the rows of one or a number of tables. But there are also many times when we just want to perform a simple calculation, or perhaps a more complex calculation, to obtain a result. This is the use we will make of the select command here. So let's perform the simplest select statement we possibly can. First, we type the word select. Then we provide something simple that we want the server to return to us. In this case, we will use the number 1. Since we are performing this operation in the MySQL command line client, we must also indicate at the end of the statement that we want the client to send our statement to the server. We do this by typing the semicolon character, which you will remember from an earlier chapter is merely a shortcut for the go command. We could also type the character string \g, however that takes one more keystroke than just typing the semicolon character, so we lazy people use the shortcut. We then press the return or enter key to send the command to the server for processing. What we see now is the result that MySQL server has sent back to us. At first glance, it looks like the server got confused because it sent us 2 rows that contain exactly the same thing. But even though these 2 rows look the same to us, they perform 2 very different functions. The second row is the data that is returned to us. The first row contains the column heading that describes to us what is in the second row. In this case, since we requested a numeric constant, the column heading is exactly the same as the data. But this is a rare thing and usually only appears in examples in classes like this one. Still, this is exactly how the server communicates with the client. To demonstrate with a different type of data, let's select a simple character string instead. So again, we type the word select, but this time we will follow the name of the command with a quoted character string. If we don't put quotes around the characters, MySQL will try to interpret our character string as the name of a variable instead of as a simple character string. And it probably won't find a variable of that name, so it will return an error message to us instead of what we asked for. We will talk more about variables later in this chapter. Again, we see in our results that the column heading is the same as the value that the server returned to us as the answer to our request. When our client program displays a character string to us, it doesn't bother putting the quotes around that character string. So the client displays character strings unquoted, but requires us to quote character strings when we include them as values in a calculation. Okay, let's try something a little more challenging. Again, we will type the word select, but this time we will follow the command name with a calculation. Let's do it 1 plus 1. And then we put in the semicolon character. When we send this command to the server and receive the result set back, it is a little more clear what has been returned to us because the column heading is now the exact expression we put into our request to the server. So now it is clear what is the request and what is the result. But as you might suspect, complex calculations can lead to some very lengthy and cumbersome column names if we don't deal with them in some other way. We will cover a solution to this issue a little later in this chapter. There are a number of other places in a select statement, and in fact, in other SQL statements as well, where we can use calculations like these. But simple select statements are great places to experiment with and test such calculations to make sure that they give us the results we want before using them in a more complex and time-consuming command. And there are still a number of issues with aspects of the columns retrieved by a select statement that we can explore in this simple way. For example, the fact that we can retrieve more than one column with a single select statement, and the mischief we can get into while doing so. Selecting multiple columns is the subject of our next lesson.